Good morning to everyone. We'll move to quadrilaterals part 3. Section 7.3 types of quadrilaterals. So in the last video, we have now learnt about angles and property of a quadrilateral. That is, a sum of angles of a quadrilateral is equal to 360 degrees. In this video, we will learn about different types of quadrilaterals. This will be an interesting video. We'll just see what are all the different types of quadrilaterals. So let us take a quadrilateral, which is nothing but a four-sided polygon. So the definition of a quadrilateral, so we will also see the definition here. Each and every type, whatever you see in the picture itself, in the diagram itself, I have written the definition. So it will be very useful for you to, when you go forward and learn about different types of quadrilaterals, their properties, theorems, whatever. So quadrilateral, the definition is four-sided polygon. Nothing else is there in the definition. So there are different types of quadrilaterals. Let us discuss in this form of flow chart. We are going to see a flow chart. Let us see now quadrilateral. It flows into what is called a, what is this? Yes, all of you know, but still I am explaining to you. This is a trapezium. A definition of a trapezium is a pair of opposite sides are parallel. So whatever I am writing in the bracket is the basic definition of that particular quadrilateral or particular shape. You can say that trapezium, a pair of opposite sides are parallel means it is a trapezium. The next one I will write is a property. So again another type, non-parallel sides in an isosceles trapezium are equal. Since we are not going to study about trapezium, I am not going to elaborate much about this. But once again, I will just say that is a normal trapezium is a pair of opposite sides are parallel. That is a top side. You can see the side at the top and the bottom, those two are parallel. If any two sides are, if two opposite sides are parallel, then it is a trapezium. And there is another type of trapezium which is called isosceles trapezium, where the non-parallel sides, that is, if you see this one, this and this, these two are non-parallel sides. This and this are parallel sides. These two are non-parallel sides. Here I have shown only isosceles trapezium. If these two sides, this and this, if these two are equal, then it is called an isosceles trapezium. You can just leave it here. You need not bother much about this because we are not going to study about trapezium in this chapter. We'll go to the next shape in the form of flow. This is a kite. This is a kite. Hope all of you know, everybody would have played kite or maybe playing kite when there is good breeze, correct? But you should not use a thread, you know, the thread, you should not use a thread with, some people use with glass. You know that, you might have heard about this. It is what it does, when somebody is going by scooter or cycle or bike, it just cuts their neck and that person dies, falls down and dies. Okay, so this kite we should use only with a cotton thread, so that in case it hits anybody, the thread gets cut. Anyway, let us not go into the details. Now again, kite also, like trapezium, we are not going to learn or study about this. This is only for your information, just to know what are the different types of quadrilaterals. So what is a kite? Let me explain. Both pairs of adjacent sides are equal. That is, if you see here, this and this, these two are adjacent sides. So if this side and this side are equal, similarly this side and this side, these two are equal. So this is called a kite. So you need not, again as I told, need not bother. Just you can understand this definition or you can just note down for future reference only. Now let us move to the important quadrilateral which we are going to study in this chapter. That is a parallelogram. Let us see the definition of a parallelogram in this page. Both pairs of opposite sides are parallel. So just important point to note, both. You see in trapezium it is a pair. There is only one pair, top and bottom. Whereas in parallelogram, both the pairs, that is top and bottom are parallel. Similarly, you can see that is this and the bottom are parallel. This left side and right side, these two are parallel. So both pairs are to be parallel, then only it is called a parallelogram. This is a basic definition of a parallelogram, but we will be studying the properties when you move forward. So this parallelogram definition is important. You can note down in your notebook before moving forward. Let's go forward. Okay, in this chapter we will be discussing about parallelograms only, as we have already mentioned in the previous video. So there are different types of parallelogram. Let us discuss this also in the form of a flow chart in the next page. Here I'll just explain certain points. You can note down these points, then see the flow chart in the next page, so that it will be easy for you to understand. Rhombus, rectangle and square have all the properties of parallelogram. These are the three types of parallelogram we are going to see in the next page, but all three have all the properties of parallelogram. Rhombus and rectangle each have an additional property. What property? We will see in the next page. Square has properties of both rhombus and rectangle. Therefore, a square is a rhombus, a rectangle and a parallelogram. So if you say a square, it satisfies all the properties of a rhombus, all the properties of rectangle, all properties of parallelogram. In addition, it satisfies all the properties. We will see in the next page again. Both rhombus and rectangle are parallelograms. The difference between these four shapes are shown in the next two pages. So what you can do, just note down all these points as it is. When you go to the next page, you will be able to clearly understand what you have written in these notes. We'll move forward. Now you can see that types of parallelograms, again, types of parallelograms are defined in this page as well as the next page. In this page, I have written only about sides and angles. In the next page, you will see about the diagonals. So parallelogram, again, the first within bracket, I have put the definition. Opposite sides are parallel. So a parallelogram means a quadrilateral where opposite sides are parallel. So that is why I put in the bracket. It is not a property, it is a basic definition. In the parallelogram, opposite sides are equal and opposite angles are equal. So you can note this point, that is this and this are equal, as we saw in the previous two pages before. This and this are equal. Similarly, this angle are equal, this angle and this angle are equal. Just I am explaining to you, but when we go to we are going to prove theorems, you are going to see the properties. There you will see the angles clearly mentioned with different colors, so you will be able to understand clearly. Now a parallelogram becomes a rhombus when all sides are equal. Now you see, parallelogram, opposite sides are equal, whereas in rhombus all sides are equal. And when a parallelogram will become a rectangle, when all angles are equal. So now you can see a parallelogram has got opposite sides are equal, opposite angles are equal, whereas a rhombus, when all sides are equal, it is a rhombus. So that means in rhombus all angles are not equal. Similarly, in a rectangle, all angles are equal, but all sides are not equal. So you should understand, that is, if it is a rhombus, the definition is, the properties are, one is all sides are equal, opposite angles are equal. So whatever properties are there for parallelogram, rhombus will have an additional property or one or more additional properties. So hope you are able to understand. Let me again explain clearly. A parallelogram has got opposite sides equal, opposite angles equal. A rhombus has got all sides equal plus opposite angles equal. Whereas if you come to rectangle, all angles are equal and opposite sides are equal. Right? Hope it is clear. I have not written again and again what is there in the parallelogram. Whatever is in bottom of the chart, in the flow chart, it satisfies the properties of the top of the chart. Now if I write the next shape, you will be able to understand thoroughly. That is square. Now I am going to give a pass. Whomever has understood what I have told for rhombus and rectangle, if you have understood thoroughly, you will be able to say what is the property of a square. Let me give few seconds. You can pause the video, you can note down what you guess and then check what I am going to tell and what you have written are correct. Yes, I am very sure most of you would have understood, all sides are equal, all angles are equal. So that is, it is combining the property of rhombus and rectangle. So let me put the flow also here. So rhombus flows into a square, rectangle flows into a square. That means square satisfies the property of rhombus, rectangle and parallel. Rhombus and rectangle, if I say, that is sufficient, because rhombus satisfies part of parallelogram, rectangle satisfies balance part of parallelogram, and if you add together it becomes a square. So in parallelogram it is only opposite sides and opposite angles are equal. In a square all sides and all angles are equal. So that is how it flows into different shapes. So in this chapter we are going to study only about parallelograms, which means what? Yes, a rhombus, a square and a rectangle, all three will satisfy whatever theorems we are going to prove for parallelogram, correct? But the opposite is not true. Suppose if we have a theorem for square, none of these three may, or all the three may or may not satisfy, because a square is not a square is a rhombus and rectangle, but all rhombus need not be square, correct? All rectangle need not be a square. So that is how the flow chart is there. The bottom ones satisfy the top one's properties, whereas the top ones will not or need not satisfy the bottom one's properties. In the next page we will see for diagonals, same thing. I have written the same definition of parallelogram. Diagonals bisect each other. So this is a basic property of a parallelogram. That is, if you see this diagonal and this diagonal, they bisect. Understand what is the meaning of bisect? We have done constructions, correct? So if it is A and C and B and D, and if there is a midpoint O, so BO equal to DO, AO equal to CO. Hope all of you understand. We are going to prove a theorem. At that time we will see with clearly the vertices will be mentioned. There you will be able to understand thoroughly. Now you can again, now you have seen in the last page, similar definitions will come here. A rhombus, in addition to bisecting each other, the diagonals are perpendicular to each other. That is the midpoint O we saw, that is AC and BD being two diagonals. When they intersect each other, the angle, all the four angles will be 90 degrees. And they also bisect vertex angles. That is, if this angle is there and if you draw the diagonal here, the half portion of this and the half portion of this will both be equal. And in a rectangle, the diagonals are equal. So you can see the additional properties there. The diagonals only one property, that is bisect each other. Here the diagonals bisect at right angles, that is perpendicular to each other, and they also bisect the vertex angles, that is rhombus. In the case of rectangle, the diagonals are equal. Now what else? Yes, I know all of you have understood now. If you are able to connect to the previous page and this page, what flow you are going to get. This is the square. Pause the video. Note down your answer, what all properties square will have, and then you cross check. I am sure all of you 100% all will be correct. Yeah, I'll give few seconds for you to pause and then note. Yes, let us proceed. Square, diagonals are perpendicular to each other, bisect vertex angles, and diagonals are equal. So a square satisfies all the properties of rhombus and rectangle. Rhombus satisfies properties of parallelogram, rectangle satisfies properties of parallelogram. And the reverse is not true. So all of you know. Parallelogram satisfies all the properties of? Yes, very good. They satisfy all the properties of quadrilaterals. Correct? So the flow of the information or flow of properties go like that. That's why it's called a flow chart. So you can pause the video, note down all these points and then move forward. Again, sorry, this flow also I am putting so that you know that rectangle and rhombus become square when they satisfy additional properties. So in this video, we have learnt about different types of quadrilaterals, that is trapezium, kite and parallelogram, and further different types of parallelogram, that is rhombus, rectangle and square. But as we said, why I have not written Parallelogram different types, because rhombus, rectangle and square are also different types of quadrilaterals. And learn some properties of parallelograms and prove theorems related to the same is going to be the next video, or not only next video, few next videos are going to be same. We are going to learn properties after properties, different properties we are going to learn that we have already seen in the flow chart. Whatever written in the green, that is diagonal one property, angle one property, sides one property. There is one more what we have seen in the red. There are about 4 or 5 properties we are going to see, and each property we are going to prove a theorem for each property. One theorem will be there, maybe some converse will be there. We will start and we will do one by one in each video. Questions? I'm sorry. Pause the video, note down the questions, and then move forward. Thank you.